Last 5.1 video lesson, we will be talking solely about scientific notation. And scientific notation is used by scientists such as Beaker here, everybody's favorite Muppet and favorite scientist. Scientists, mathematicians, engineers, basically anybody who's ever used numbers can use scientific notation as a way to describe numbers in an easier way. So this number here being 4,560,000, we can say that in a much quicker and easier fashion, displaying it numerically. Or if we're talking about things that are very, very small, such as this one over here, again, we don't have to write the decimal point and put all the zeros after it. Say that we were talking about something very, very small, so there were a ton of zeros in front of it, like 20 zeros beforehand. We don't have to write all those zeros, we can just write it in scientific notation. And scientific notation basically just means simplifying a number down into a point where you can use it as another value times 10 to a power, or times 10 to another exponent. So how we would do that is, again, for this number, the 4,560,000, we recognize that our decimal point is right at the end there. And to get it down to that smaller value, we'd have to move the decimal point over 1, 2, 3, 4, 5, 6 times, and we're moving 6 times to the left. So when you move it to the left, we have to multiply by 10 to a positive value. So our new number then, once our decimal point is over here, would be 4.56, and we need to multiply that by, since we went over 6 times, it would be 10 to the positive 6. So we would write 4,560,000 as 4.56 times 10 to the 6th. Now if we wanted to write our number over here, again we need to get the decimal to the next, like the nearest digit that would be usable, and we want it to be in between 1 and 10. So we have to move it over 1, 2, 3, 4, 5 times to get it there to our 9, because 9 is in between 1 and 10. We wouldn't want it to be 92 over here, because 92 is not in between 1 and 10. We want the 9, so that becomes 9.2, and we moved it over 5 times, but we moved to the right. So when you move right, you have to use a negative. Sorry, Beaker, right on your nose there. So in this case, we'd be multiplying by 10 to the negative 5. So that number would be 9.2 times 10 to the negative 5. Now when we're multiplying numbers in scientific notation, this is an instance of why the scientific notation makes things so much easier. 5 times 10 to the third power would be 5 times 10 to the 1, 2, 3, or 5,000. And 7 times 10 to the 8th power would be 7 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, which if we put in our commas, that looks like it would be 700 million. 700 million. That's a really big number. So instead of having to punch 5,000 times 700 million into our calculators, we don't want to do that. We can just multiply the numbers out front, our constants, to get 35, and multiply our tens that we are using, 10 to the third and 10 to the 8th, which again, as you remember, when you have the same base, in this case the base of 10, so it would be exponent times exponent, you're using addition. So this one is going to become 10 to the 3 plus 8, or 10 to the 11th. So we can take that away and just say that it's 10 to the 11th. We're not quite finished on this one because 35 is not in between 1 and 10, so we want 3.5, which means we had to move it over to the left one more time. So we have to make it our 10 to the power of one more, or one bigger, one more positive. So 3.5 times 10 to the 12th power is our final answer. Again, if we want to do another multiplication problem with our scientific notation, 1 to the 8th or 1.8 times 10 to the negative 4 is again going to be a very small number. That would be 0.00018, because we had to, from here, move our decimal over 1, 2, 3, 4 to the left. So this is how you could write it, and then times again 4 times 10 to the 1, 2, 3, 4, 5, 6, 7th power. So that one would again be a 40 million. So we don't want to use those numbers to punch into our calculator. We can just use our 1.8 and 4 would multiply to 7.2. And our 10 to the negative 4 and 10 to the 7th would become times 10 to the negative 4 plus 7 is 3. So we have 7.2 times 10 to the 3rd power. And since 7.2 is in between 1 and 10, we can just leave it as is. So that is our final answer right there. For this problem, we're using dividing numbers in the scientific notation. And we kind of have a fairly real-life situation. It says there are 5 times 10 to the 6th number of red blood cells in 1 milliliter of blood. A certain blood sample contains 8.32 times 10 to the 6th red blood cells. How many milliliters of blood are there in the sample? Well, we want to set this up the same way we would set up a similar problem, say like with apples. If there are 4 apples in a basket and a certain group has 20 apples, this is going to be my apple. How many baskets do we have? Well, we'd take 20 divided by 4 to find out that there are 5 baskets. So we want to set it up in a similar way to say that we have 8.32 times 10 to the 6th red blood cells in our sample, in our larger group, and we need to divide that by 5 times 10 to the 6th is the amount of red blood cells in 1 milliliter. So this will help us find how many milliliters there are. Well, like we did before, we recognize that there is a base of 10 on both the numerator and denominator. So we can take away from its exponent, or to the power, we'll take away 6 from this side, or 6 from the numerator and 6 from the denominator, leaving 10 to the 0th in both instances, which both of them just become 1. So that becomes 8.32 over 5 is what we're left with. And if we were to punch that into the calculator, that would give us a 1.664. So we'd be left with our answer of 1.664 milliliters of blood are in that sample. So we could say milliliters at the end. So these are examples of how we would use the scientific notation